Hi, this is Hao. The topic of my project is refractory epilepsy detection. First, we'll introduce the background. Drug resistance is a major clinical and societal problem for 1 in 3 epilepsy patients. In this paper, our aim is to identify epilepsy phenotypes by conducting rule-based methods and machine learning algorithms. First, we'll introduce our feature construction method. First, we'll need to define non-refractory patients as control group and refractory patients as case group. Patients in case group are who failed with at least 4 AEDs, and patients in control group are who failed one and only one. And then we need to pre-process data and get case group and the control group. Because our dataset contains many kinds of diagnoses, we need to filter the dataset and get the population we really need. Thus, we designed a filter rule to get epilepsy population. The rules are first, patients should have at least 1345 or at least 2780.39 at any time in the data. Second, patients should have at least one AED claim from a stable pharmacy. Third, the age of a patient should be 16, should be at least 16 at the index date. As the figure shows, the number of case patients is 203, and the number of control patients is 7,096. Then we need to do feature construction on content on control dataset and the case dataset. We only select the data prior to the index date for feature construction. We also apply an observation window. That is, we only consider 1 year of data prior to index date. The reason is to prevent bias in the model for patients who have more data. I selected patients including hub states, diet code, pro code, molecular drug name, class name, supply days, drug names, and the quantity drug name as features. Features like diet code, molecular drug name, they are categorical data. So we use their counts as the feature value. For quantity drug name and hub states, because they are quantitative values, we can calculate their average values as patient's feature values. Then we need to do normalize features values into same scale by min-max normalization methods. I map each patient's max value as 1 and the other feature values as the max value, subtract the current value. Finally, we can get the feature values we want. After we get the features, we can apply classifiers on them to make prediction. Here we use 3 classifiers: SVM, logistic regression, and decision tree. And here are the experimental results. I developed the experiment in Python, and I used the classification algorithm from scikit-learn. For logistic regression, I use autonorm and set max iteration as 100. And for SVM, I use radial basis function kernel. And for decision tree, I use Gini impurity to measure quality of space. Here is the ROC curves. As picture shows, we can see that the logistic regression gives the best performance, because that is because logistic regression has the best scalability among the 3 classifiers. In conclusion, in this study, a rule-based method used to filter dataset and construct features. And in the future study, I will explore more on feature constructions and try to take more features into account. Thank you.